Hey everybody, another lesson. So, by the way, I want to say I don't know if you read on my website that's on Don Lugo. It says on there that we're going to do like 3 or 4 assignments. We're going to upload assignments every Monday, and then you need to do those by Friday, and will be available on Tuesdays and Thursdays during specific time slots to help you out with any questions. The meetings are not mandatory, they're optional. Just if you need help on any of the problems that you see in the little assignments that we post. And we're going to choose a random assignment during the week and make that your quiz score. So assignments, will count them as normal 10, but a random assignment will be chosen and will give you the score actually given to you for that assignment. So you want to do the best you can on the assignments that we post, and you want to do them all in case you don't want to miss the one that might be the random quiz. So make sure you work hard on those assignments. They're not long. They're fairly short, and they're based off these lessons. So the next lesson is numbers 7 and 8. 7 and 8, they talk about drawing the angle of rotation, which on the test you won't have to draw the angle of rotation, but on the quizzes you will have to recognize the angle of rotation. Quiz assignment. On the assignments that you'll have to recognize the angle of rotation, but I couldn't find an app where you actually physically draw the angle of rotation. So number 7 here, it says draw the angle of rotation. So remember that the angle of rotation, well, let me go back to your notes for angle of rotation. That was February 26th. Okay. Standard position, vertex is at the origin, one ray is the positive x-axis, so that would be the initial side. The terminal side is the one that moves around, remember, that rotates. So it's the angle formed by rotating the terminal side and keeping the initial side in place. So, drawing the angle of rotation for 967, start with your initial side, and then we're going to go, it's a positive 967, so we are going to go counterclockwise. You can't tell, that's an arrow, I just noticed. We're going to go counterclockwise, but how much counterclockwise? So to try to figure out how much counterclockwise the angle of rotation would be, we have to figure out how many loops around, because 967 is definitely bigger than 360. Let me switch to document camera only so you can just concentrate on that, and then I don't have to worry about looking at the camera. So 967, where should I do the work? I'll do the work over here. 967. We're going to subtract 360 until we know where it lands. Okay, so 967 minus 360 is 607, which is still bigger than, too big. That's still too big to do on the units, on the circle. So 607 minus 360 again. Let me show my work. 247, which is something we can graph because that's between 0 and 360. 247, if you remember your unit circle, 247, well, this is 180, this is 270, so it's in between here. So just draw it in between here. And remember, each one of these is a rotation. If I could spell it, rotation. There we go. Okay, so each one of those is a rotation. Notice I made 2 rotations. So when I do my loopy, I need to snail it out. So we have 1 loop, 2 loop, and then we end at the initial side. That would be 967 degrees. There we go. So that's my angle of rotation right there. It says which quadrant or axis is the terminal side on. If you remember quadrants, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So 1, 2, 3, or 4. And I believe on the test I have it listed with the Roman numeral, the I's and the V's, and with the actual physical number 1, 2, 3, and 4. So which quadrant or axis is the terminal side on? The terminal side is pointing to quadrant 3, so that's 3. What is the measure of the reference angle? Now the reference angle, here we go, reference angle, it's an acute angle. It's between the terminal side and the x-axis, and one other thing, it's always positive. Okay, it's always positive. So the reference angle would basically be between the x-axis and the terminal side, this, and we're going to mark it as a positive. So if we take out the rotations, we take out 360, we take out 360, we have 247 degrees left. And that goes from here all the way to here. We don't want this part. We want to get rid of that. Well, getting rid would be subtracting. Well, from here all the way around to here is 180. So we're going to take our 247, and if we subtract out this 180, we get this angle that's left. So minus 180. 247, so I already have that on here, minus 180 is 67 degrees. So that means the measure of the reference angle is 67 degrees. There we go. So number 8, now this one's a little bit different in that it's a negative rotation, which means we're going to go counterclockwise. It's bigger than 360, or negative 360, however you want to look at it. So it's going to make a loop. So we take our negative 404, and we want to subtract out a rotation. Well, it's negative, so subtracting out a rotation would actually be adding, and that would get rid of a rotation. So negative 404. 404, make it negative. And then we're going to add the rotation to get rid of it, which sounds a little backwards, but that's just how it is. Okay, we're back. I think we're back. Yeah, we're back. Okay, so what I was saying, I don't know if the sound messed up, so I'm going to repeat. Negative 404, we add 360, we get negative 44. Okay, so that is negative number, which is difficult to graph negative numbers on here. I mean, we can change this to negative, but I don't like doing that. I like finding the positive degrees so I know where to go. I just have to remember that my arrow is going to go backwards, counterclockwise. So what I'm going to do is I'm going to add in another rotation so that I can find out the positive degree that I need. So plus 360 is 316. So I know 316, well, this is 270. This is 360, so 316 would be between 270 and 360. So it's going to be in here somewhere. Okay, so that's my terminal side. So when I draw my loop, remember I have to go backwards because it's negative. So I'm going to go backwards. I had a full rotation. This is a rotation. I'm going to land here, so I don't need to worry about this rotation. That just helped me find the degree, so I don't need to worry about that. So this is negative, there. This is negative 44, which actually is negative 404 because we looped it. So all the way around is 360, and then another 44 degrees gives us that. Okay, as for the reference angle, oh wait, so draw the angle of rotation. I did. Which quadrant or axis is the terminal side on? That would be 4. It is right here. That's the 4th quadrant. And then what is the measure of the reference angle? Positive angle, remember, acute and positive, between the terminal side and the x-axis. So we need to know this angle right here. So let's see, basically it's however many degrees that is from the x-axis, which we knew that was negative 44, but since it has to be a positive degree, we make it a positive 44. And we put a degree. So this is 404 degrees total, and we had to get rid of, now I'm not talking about negative, we're just talking about the degrees, not the direction. The negative is the direction. So I have to get rid of a full circle, and once I get rid of the 360 degrees, I have 44 left for that part. So that gives me 44 degrees for my reference angle. So that would be it for this video. So you check for the next video on another assignment. This is for the assignment about angle of rotation and reference angles.